By the end of this video, you are going to have expert knowledge of what DMX is, why it was invented, how it works under the hood, and why it is so widely used today. Also, be sure to stick around to the end of the video when I cover some of the important limitations of DMX and how to get around them. First and foremost, DMX 512, which is often just referred to as DMX, stands for Digital Multiplex, which has 512 pieces of information. I know, it's a dry name, but it's for a good reason. To understand why DMX exists in the first place, let's take a look at the innovation in entertainment lighting. Lighting started out very simple. This image was from 1928. Lighting used to be controlled using these large panels that required a manual operation. If you wanted to turn a light on, you had to flip a switch. As you could imagine, this was very inefficient. With the advancement of electronic technology, electronic dimmers were created that could provide computerized dimming of many channels of light at the same time. This led to another problem though. Each manufacturer had a different protocol and the systems were not cross-compatible with one another. As the industry grew and shows became more and more complex, the need for cross-compatible equipment was even more important. In order to fix this, the USITT Engineering Commission sponsored a session at their annual conference. And by the end, they had started a project to develop a lowest common denominator control protocol that would be able to communicate with everything. And in turn, the lighting manufacturers would have to support it in their products. Thankfully, it was widely adopted and is the most widely used control protocol today. Now that we know why DMX exists in the first place, let's explore how it works under the hood. The DMX protocol is actually very simple. It is divided into two discrete components. We have the address, and then the value that is associated with that address. The DMX 512 protocol has, 512 addresses, each of which can be a value between 0 and 255. You might be wondering why the values are between 0 and 255 and not 0 and 100. This has to do with the underlying data types. In computers, we use bits to represent data. Those are either ones or zeros. In order to do anything useful with bits, we need to combine them into larger groups to hold any meaningful data. The next step up is a byte, which is a grouping of 8 bits together. And if we do 2 to the power of 8, we can see that's where 255 comes from. The 512 addresses together make up what's called a DMX Universe. DMX uses a 5-pin connector. You may have come across a 3-pin connector in the past. However, these are not permitted to be used according to the DMX specification, but that doesn't stop people from using it anyways. The two main differences between the cables are future features and impedance. There are currently unused pins on a DMX connector that are reserved for future expansion and features. These have been used for bidirectional communication in the past, but that hasn't been widely adopted yet by the industry. But arguably, the most important reason to use a 5-pin connector is that the cable is attached to it has the proper electrical characteristics. While it may seem that the 3-pin cables work, you will run into issues when you have longer cable runs. One important feature of DMX is that it is able to be daisy chained. This means that you can connect many devices together in a chain with the output of one fixture going into the input of another fixture. This works great in theater especially, since we normally have lights lined up in a line anyways, and it is easy to jump from one fixture to the next. Once we have connected our final fixture to the DMX daisy chain, we need to terminate the end. Some devices have a terminator built in, but if they don't, you can always purchase one online. DMX termination is very important. Imagine if you were in a very large room and you yell. You will expect to hear an echo of yourself. This is the exact same thing that happens inside of a DMX cable without termination. The signal gets reflected back and can confuse the devices connected to it. This can cause instability, flickering, and other issues. Lights have come a long way and often have many parameters that we can control, such as pan, tilt, iris, color, gobo, and much more. Each of these parameters are controlled by one or more addresses. Since the DMX protocol sends all information to all devices, it is up to the receiving device to take what it needs. We set the starting DMX address for each light by either using a digital display for newer devices or a dip switch for older devices. Now we need to generate a DMX signal to feed to all of our devices. Light boards are what we normally use to control lights. These devices contain an operating system that allow us to program what we want our lights to do, and then convert those commands into a DMX signal. I personally use a desktop software called ETC Nomad, and its corresponding box that generates the DMX signal. You will notice that this box has two plugs, which corresponds to the two DMX universes. This brings us up to the big limitation of DMX, which is that we are limited to 512 addresses per universe. And with intelligent lighting fixtures these days, using many addresses, they run out of data very quickly. The solution for this issue is to keep adding more and more universes. Thankfully, there have been new protocols developed to distribute many universes of DMX over one cable. However, they all still require to be converted back into actual DMX before being plugged in. I am planning on doing a full video just on these protocols in the future, so be sure to stay tuned if you are interested in this sort of thing. If you found this video useful, feel free to give it a thumbs up and consider subscribing to support the channel. And I will see you next time.